The first thing the war demanded was movement, not glory, not tanks, movement. On the Normandy beaches, trucks rolled out of landing craft into the surf, engines coughing as sand swallowed their tires. In the mud of field hospitals, more trucks arrived carrying men whose lives depended on a gearbox working just one more hour. Civilian hands scrubbed the wheels clean in cold village streams because the fighting couldn't wait for workshops. Beneath all of it sat a simple mechanical truth. Without a steady stream of fuel, food and ammunition, even the finest divisions would freeze in place. A war can survive 1,000 plans, but not one empty lorry. The Second World War began with an unromantic truth. The Allied armies did not possess enough wheels to match the scale of the war they were about to fight. Britain's pre-war motor pool was a patchwork of civilian lorries, requisitioned vans, aging military trucks, and an industrial base still trying to remember how to build in true mass production fashion. The map of Europe was collapsing faster than supply departments could draw new lines on it, and the early retreats showed a simple, brutal fact. Infantry could march, tanks could fight, but armies could not move unless thousands of trucks stood ready behind them. Industrial planners recognized the gap immediately. Britain's existing vehicle industry excelled at building small batches of specialized machines, but global war demanded something colder: repeatable production, interchangeable parts, and construction lines measured in miles rather than yards. Supply officers reported shortages not just of trucks, but of spares, tires, tubes, lubrication oils, and repair teams. Bridges groaned under unexpected loads. Roads that had survived centuries of trade collapsed under a single week of heavy convoys. Commanders found themselves forced to plan operations around the lorries they wished they had, rather than the ones sitting on their strength returns. The technical problem behind this crisis centred on three mechanical realities. First, early war British lorries were often built around commercial engines, tuned for economy rather than torque. In France and North Africa, these engines overheated under convoy loads, where vehicles moved slowly, hauled hard, and rarely found clean airflow through their radiators. Second, many chassis designs lacked the reinforced cross members required for prolonged off-road service, leading to frame twisting under repeated load cycles. Third, braking systems, still largely mechanical on several pre-standardization types, showed alarming fade on long descents, placing both men and material at risk. Operational doctrine amplified these engineering faults. The British Army had long assumed that railways would remain the core of strategic movement. When the war demanded rapid motorized columns and dispersed mechanized brigades, the existing truck fleet simply could not lift the required tonnage. The retreat across North Africa exposed every weakness. Sand ingestion choked carburettors, fuel evaporated in heat, suspension springs snapped after days of corrugated tracks, and maintenance crews, lacking spares, were reduced to cutting usable components from wrecks in the desert sun. The stakes, by 1941, could not have been higher. A modern war demanded a constant flow of ammunition, food, fuel, replacements, tools, bridging gear, radio batteries, medical stores, and recovery equipment. Without a massive expansion of truck production across Britain, Canada, and the United States, the Allied armies would remain tactically capable but strategically paralyzed. Advances would stall, counterattacks would fail, and mobile operations, the very essence of 20th century warfare, would become impossible. In response, Allied logisticians drafted requirements that would reshape wartime engineering: higher capacity cooling systems, quick change air filters for desert dust, standardized wheel stations, multi-fuel compatibility, and strengthened frames capable of bearing both cargo and improvised bodies in theatre workshops. Each specification reflected a battlefield lesson bought at cost. And yet, procurement officers continued to argue over seemingly trivial details: tyre widths, gearbox ratios, load bed lengths, and whether wooden bodies should give way entirely to steel. It was said that the surest way to halt an entire battalion was not enemy fire, but a quartermaster, discovering his trucks used the wrong sort of wheel nuts. By the end of this phase, the Allied powers had reached a consensus. The war could not be won by tanks alone. Victory required fleets of trucks vast enough to stretch beyond the horizon and reliable enough to keep moving across continents. The idea of an Allied truck war did not begin in a factory, nor even in a headquarters, but in thousands of small decisions made by officers facing a continent whose distances swallowed men and fuel with the same indifference. In these rooms, the air stiff with cigarette smoke and maps pinned like pressure points, planners sketched a vision of movement that refused to depend on any one nation's engineering tradition. The British wanted dependable cross-country mobility. The Canadians pressed for universal mechanical parts. The Americans demanded a truck that could be built fast enough to feed an army growing by the hour. From this stew of strategic need emerged the guiding doctrine: mobility must be standardized, maintainable, and mathematically predictable. This principle collided with competing ideas. British quartermasters argued for a family of trucks in carefully tiered weight classes, each tied to a specific tactical role. American logisticians pushed the opposite direction. One universal workhorse, the 2.5-ton 6x6, used for nearly every purpose short of towing a battleship. Canadian designers at Ford and GM added their own logic: simplify the cab, rationalize the body shapes, and allow any workshop from Burma to Scotland to replace a cracked component with whatever happened to be in the crate that week. The result was a doctrinal ecosystem rather than a single blueprint. Technical arguments were fierce. Tyre width became a strategic issue in muddy theatres. Whether a truck carried a low-revving petrol engine or a torquey diesel affected not just range but the size of fuel convoys behind it. And the question of two-wheel versus six-wheel drive decided whether a logistic column survived the winter roads of Italy or expired on them. In the middle of these discussions, someone inevitably brought up payload tables or axle load calculations, prompting a long silence, broken only when an officer realized that the entire front hinged on the tensile rating of a single leaf spring. Yet the conceptual clarity sharpened. A truck must not only carry weight, it must do so with parts interchangeable across hundreds of thousands of vehicles. The electrical looms had to be simple enough for a sapper with numb fingers to repair. Cab ergonomics had to allow a driver to stay alert for 12 hours without roasting or freezing inside a steel box. Even the cooling system became an ideological battleground, with desert crews demanding high-capacity radiators, while British designers insisted that overwrought cooling added unnecessary manufacturing hours. It was here, in the conflict between theory and production reality, that the true vision of the Allied truck emerged, a machine defined not by glamour, but by a reduction of variables. Every extraneous bracket, every awkward bolt, every idiosyncratic gear ratio risked immobilizing a column at the worst possible moment. To an engineer, a truck was perfect, not when nothing more could be added, but when nothing else could break off on the way to the front. That dry humour hid a serious truth. Simplicity was the only form of reliability that could be mass-produced. By the time the planners nodded to each other across their map tables, a doctrine had crystallized. Trucks would not merely supply the war, they would shape how the war itself was fought, determining the tempo, reach, and survivability of the Allied armies. The vision was not elegant, but it was effective, and soon its consequences would roar across continents. The factories did not roar, they hammered. In every Allied nation, wartime assembly lines pushed out trucks with a discipline that bordered on ritual rivet, lift, fit, repeat. Each operation existed at the mercy of tolerances no wider than a fingernail, because a truck with misaligned bearings or a crankshaft ground a fraction too thick would fail the moment a supply route turned against it. The war demanded precision on an industrial scale. and the Allies answered by turning workshops into disciplined machines of their own. Machining came first, steel billets, rolled under shortages and substitutions, arrived in great stacks that carried the dust of different continents. British factories used manganese-rich alloys when high-grade steel ran short. Canadian plants reprofiled stamping dies to preserve wear life. American workshops rotated shifts specifically to preserve the tempering cycles of crankshafts. Nothing was simple, nothing was stable, but everything had to fit. From the autocar 2.5-ton tractor to the Bedford QL, each component followed a template rewritten weekly by shortages, battlefield reports, and the sheer persistence of men and women who refused to let production stall. Assembly was staccato by nature. A chassis rolled onto the line, bare, angular, waiting springs dropped into place, axles aligned by chalk marks and shouted measurements, wiring looms snaked over frames like nervous systems. Engines arrived on overhead cranes, dangling like the heart of a mechanical organism. Fitters used feeler gauges polished smooth by constant use. Welders worked in booths that glowed like furnaces, and every single truck, from Britain's QL to the American GMC families, had to meet a standard that ignored the chaos outside the foundry gates. There were quirks. British gearboxes often required micro-adjustment of selector forks after installation. Canadian CMP cabs, made from angular stamped panels, needed manual reflanging when dies wore down. American carburetors demanded altitude tuning depending on expected theatre. These were not errors. They were the invisible signature of wartime industry stretching beyond its design limits. Production lines learned to fight shortages with ingenuity. Lubricants arrived thin. Factories added recirculating filtration rigs to extend their life. Rubber allocations dipped. Tyres received reinforced canvas plies to compensate. Electrical copper was rationed. Looms swapped to tinned steel strands in non-critical circuits. The trucks that rolled out were not identical twins. They were siblings with shared purpose and slightly different bones. The pace was relentless. If a machine broke, production workers stripped their own lunch carts to improvise spacers and brackets. If a shipment of bolts failed hardness tests, engineers redesigned joints overnight, and if a line foreman said the day's quota was realistic, the ministry immediately doubled it. One could almost hear the factories grumble, "Yes, I'll build another 1,000, but only because you asked nicely." 3 new engineering truths emerged. First, the Allies mastered modularity. Axles, hubs, electrical components, and fuel systems shared interfaces across multiple truck families. Second, calibration became doctrine. Fuel pumps and ignition coils received standardized test rigs, letting multiple plants output interchangeable parts. Third, assembly speeds were synchronized with training speeds. New mechanics were drilled on the exact sequence of a line build, so field repairs mirrored factory logic. The result was not glamour. It was reliability by discipline. And while no worker on any line could see the full war from their station, each bolt torqued and each joint welded made the eventual advance not only possible, but inevitable. The trucks move, engines low, tyres searching for grip in mud that behaves more like a liquid than ground. The proving grounds are no longer fenced rectangles behind depots, but the actual front, roads half destroyed by shell fire, detours cut by engineers in the rain, and gradients that challenge every gear ratio ever drafted onto an engineering sheet. Observers stand beside them with notebooks, timed stopwatches, and the grim expectation that the next bend will either confirm the design or reveal its flaw. The British test teams focus on load vibration behaviour, measuring how supplies settle or shift over corrugations. The mathematics is immediate. Increased oscillation multiplies breakage rates, which then multiplies wastage, which then erodes the operational day count a unit can stay mobile. They watch leaf springs compress nearly flat under ammunition crates. They log axle housing temperatures as they rise on long climbs, and they mark, with unspoken resignation, the trucks whose gearboxes begin to chatter under torque spikes. American evaluators running the Red Ball Express corridors treat every run as a rolling laboratory. Fuel consumption per mile is recorded down to tenths, because convoy spacing and depot intervals depend upon it. Drivers report steering effort on rutted verges. Some note that fatigue sets in far earlier when the vehicle begins to tramline at night time. The blackout marker lamp patterns are tested for visibility at regulated distances. A driver who sees too much risks giving himself away, too little, and the column loses coherence. Each datum is absolute. Nothing is cosmetic. The Canadians concentrate on cooling efficiency, radiator airflow across long pulls, because their trucks often operate in harsher gradients and broader climate swings. They run instruments across water jacket surfaces, checking heat dissipation curves. They monitor the pressure equalization in brake systems after repeated halts on steep ground. They note how quickly a clutch plate recovers after slipping under load. It is not glamour, but it is survival. The ANZAC contingents test for dust ingress filters are removed at strict intervals, weighed dry, brushed, weighed again. The data forms a line of arithmetic that directly dictates how far a column can reach into arid terrain before it becomes its own maintenance problem. Canvas seals are examined for wear. Gaps in door moulding become, in the sand, something close to mechanical sabotage. The test officers issue adjustments, shorter service intervals, revised stowage patterns, reinforcement of vulnerable seams. Every modification is logged, ratified, and passed upstream. One British officer, tasked with reviewing driver feedback, writes a deadpan marginal note next to a complaint about steering resistance. Solution: employ drivers with sturdier arms. Weeks later, the steering box ratio is quietly altered. Meanwhile, the trucks continue. Forward. Always forward. Tires deform over stones, springs flex, chassis frames twist by measurable degrees. Observers with clipboards do not simply look, they listen. A faint change in the pitch of a differential is captured, and compared with earlier notes, a gearbox that was smooth in the morning may grind under identical conditions in the afternoon, recorded as heat-related expansion variance. The landscape becomes a partner in the testing process, contributing humidity, temperature fluctuations, and outright hostility. Rain causes silica paste to build between brake drums and shoes. Snow forces ignition tuning changes. Tropical heat punishes every fluid and gasket. The trucks endure all of it, and their behavior becomes the raw truth from which doctrine is forged. These tests are not ceremonial. They are the foundation material for planning entire campaigns. A truck type that can reliably complete 100 miles per day with a specific load becomes a metric that shapes fuel allocations, road repair priorities, and divisional tempo. Out here, the silence after each recorded observation says more than the data line itself. A note made in pencil may later decide which unit receives which vehicles and which roads are designated for which formations. The trucks are being judged not by engineers alone, but by weather, friction, time, and the constant demand of armies that must keep moving. The institutional record shows the moment the Allied truck fleets shifted from useful to utterly decisive. At every regulating point, staff officers spoke of convoys moving with a consistency that railways, pipelines, and depots simply could not match. Yet the breakthrough was conditional. Every mile gained pulled the armies further from ports and railheads, creating a logistical tide whose surface looked smooth, but whose depth hid a constant threat of collapse. Dual-clause assessment dominated the period. Trucks extended the spearhead, trucks strained it. The Red Ball Express demonstrated both sides simultaneously. Its organization channeled thousands of vehicles into a one-way traffic loop, feeding the front at a pace that outstripped German ability to redeploy. Yet maintenance workshops at the rear calculated that no more than half the fleet was serviceable at any time. Pallets, drums and rations arrived faster than paperwork could register them, and consumption curves rose far beyond early staff projections. Speed achieved victory. Speed consumed machines. Visual evidence from Caen's ruined approach roads adds another layer. Convoys weaving through rubble fields face structural failures in chassis rails, tyre blowouts from masonry fragments, and chronic bearing fatigue war diaries note that even fresh engines suffered carbon fouling within days thanks to dust-choked intakes. In this environment, tactical success depended on how quickly damaged trucks could be pulled off the route before blocking it. The Mack wreckers, visible in contemporary photographs, were therefore not luxuries but key operational enablers. Their cranes lifted broken vehicles clear in minutes, preventing entire columns from backing up and immobilizing whole divisions. 3 new operational insights broaden the picture. First, fuel-to-delivery ratios became a limiting parameter. Some trucks burned a quarter of their cargo simply to reach the line of departure. Second, staff officers discovered that convoy spacing, when narrowed to increase throughput, exponentially worsened accident rates. Planning tables had to be rebuilt from empirical data instead of doctrine. Third, the concentration of trucks on predictable routes created a strategic vulnerability that Allied air superiority alone prevented the Germans from exploiting. The period therefore reveals a paradox. Allied trucks produced the breakthrough precisely because they operated at the edge of mechanical and organizational failure. One staff officer dryly recorded that the supply system worked perfectly, except on the days it was actually used. The truth behind that line is sober, but critical. Victory did not come from invulnerable machines, but from fleets pushed hard enough to reveal, and then overcome, their own limits. The photograph of British crates stacked beneath an American gantry crane tells a quieter story than the battlefront ever admitted. The trucks that thundered across France, Italy, Persia, and Burma created an invisible empire of labour, fuel, paperwork, and wear, an empire so vast that no commander could see it whole. The convoy was only the final link in a vast chain stretching back to US marshalling yards, where British contracts, American procurement systems, and Commonwealth shipping rules collided with polite bureaucratic violence. Every crate moved by forklift in those yards represented another paragraph in a transatlantic argument about priorities, octane ratings, axle load limits, or which nation's factories could afford to retool again. The first hidden consequence came in economics. Allied trucks consumed staggering quantities of petrol, tyres, and spares, and each nation had pledged the same meagre global pool of rubber. Britain substituted reclaimed rubber compounds. Canada rebalanced industry to prioritize tyre production. The United States reorganized refinery outputs to feed convoy engines with consistent octane, because mixed batches had caused knocking severe enough to destroy pistons. A second, unexpected effect emerged in manpower. Every additional mile driven by a Bedford, CMP or GMC required mechanics, clerks, depot foremen, and drivers who were never replaced at the front. The truck war quietly drained infantry battalions of mechanically minded soldiers because armies could replace riflemen quickly, but not fitters who understood carburetor behavior in extreme climates. A third consequence took shape in the realm of diplomacy. The Red Ball Express may have appeared American, but its momentum depended on British allocations of dock labour, Canadian shipments of spares, and ANZAC workshops capable of rebuilding engines others would have scrapped. Even the length of a convoy route affected negotiations. French authorities complained that Red Ball traffic damaged their hastily repaired roads. Military governments replied that without such wear, the advance would halt. One British liaison officer remarked dryly that logistics had done what diplomats could not: force every Allied nation to speak the same administrative language. It was the only war in history where a misplaced spanner could trigger an international disagreement. Perhaps the most profound hidden consequence, however, lived in perception. Tanks and aircraft became the icons of victory. Trucks became forgettable. Their enormity, the roads laid for them, the bridges strengthened for them, the ports expanded for them, vanished beneath the narrative of heroism. Yet the forgotten infrastructure shaped post-war economies. Highways followed wartime convoy routes, vehicle maintenance standards entered civilian legislation, Allied nations emerged with workshops and technical schools forged from expeditionary necessity. What began as a fleet of trucks ended as a blueprint for industrial modernity, quietly imprinted on every nation they served. Victory left the Allied truck standing in the quiet that follows a storm, its steel frames cooling on roads that no longer shook with urgency. The armies demobilized, thousands of these vehicles rolled into new careers, some into municipal fleets, some into farmers' barns, and others into scrapyards where the war's mechanical detritus formed an unexpected industry of its own. Here, lessons calcified into the next generation of transport, cab geometry, suspension load paths, and modular bodywork, all refined first on fields that once demanded total obedience to terrain engineers, traced the post-war civilian boom back to these trucks. Their chassis strength informed tonnage limits for early 1950s lorries. Their wartime carburetor standards fed directly into commercial fuel efficiency equations. Their axle ratios shaped municipal procurement policy across Britain, Canada, and the United States. Even the recovery trucks, the wreckers and winch lorries, left a heritage in heavy-haul industries, where the combination of boom crane geometry and torque-managed gearing became a baseline for breakdown services for decades. The Allied fleets also reshaped international supply doctrine. Commonwealth countries retained CMP derivatives as late as the 1970s, their robustness preferred for remote territory where road infrastructure mirrored wartime conditions. Meanwhile, the United States GMC lineage influenced NATO standard logistics. Military engineers noted that payload-to-maintenance ratios achieved by these wartime trucks established expectations still referenced in procurement files of the 1960s. Three new insights emerged in this era of peacetime adaptation. First, the practice of interchangeable cabs and beds, born of wartime urgency, became a guiding principle in commercial truck manufacturing. Second, convoy spacing models, initially derived from Red Ball Express mathematics, were absorbed into civil highway traffic planning, particularly for freight corridors. Third, the evolution of recovery vehicles accelerated urban emergency engineering, as the heavy wreckers demonstrated that crane-equipped chassis could be repurposed into specialized infrastructure machines. In many ways, the trucks outlived the ideas that built them. Armies moved to diesel power plants, synchronous transmissions, and improved electrical systems, yet the foundations remained visible. Workshops restoring surviving vehicles today often note tolerances that would surprise modern designers. Steel thicknesses were generous, welding patterns conservative, and drivetrains deliberately understressed, characteristics that would later be marketed by manufacturers as reliability features rather than wartime necessities. The irony is that a design philosophy born of fear, build it so it won't break on the worst day, became a selling point once the world wasn't actively destroying itself. Their legacy sits not only in museums, but embodied in global freight culture. Every motorway convoy, every long-haul column, every construction site bearing the grunt of diesel under load carries a direct ancestral link to those wartime machines. They were prototypes for a future where logistics would become the backbone of world economies. And as the last surviving wartime trucks rumble across heritage rallies, their engines still echo the original directive: carry the weight, preserve the line, keep the world moving. The final weight borne by the Allied truck was never measured on any scale. It lay instead in the accumulated strain of every road dragged into service, every gradient endured, every load slung over a tired chassis. The front never paused to thank the vehicles that carried it, nor did the crews imagine they were shaping a continent's momentum. They simply drove because the war demanded movement, and movement demanded trucks. The burden motif returns here not as exaggeration, but as engineering truth. A fully laden Bedford or GMC placed several tons through a frame designed originally for civilian commerce. The reinforcement plates riveted into late-war production runs were a physical admission that expectations had shifted. The conveyor of war had become a machine of war in its own right. Axle housings thickened, spring packs multiplied from 5 to 7 leaves, and heat-treated steels replaced mild grades as the Allies pushed further into contested ground. It is in these unnoticed adjustments that the real story of the Allied truck resides. Engineers understood that increasing payloads shifted not only structural stress, but operational tempo. A heavier truck demanded longer braking distances on unmetalled roads. In North Africa, drivers learned that sand robbed them of up to 40% of their available tractive effort. In Iran, the trans-Persian routes forced convoys to ascend gradients brutal enough to cause vapor lock in carburetted engines long before spares arrived. These were not the glamorous struggles of armour or artillery, but they were the mechanical facts that dictated how swiftly a division could breathe. Logisticians came to see the truck as a kind of rolling equation, weight carried versus weight consumed. Every gallon burned was itself a logistical burden, but every gallon delivered extended the fighting life of an armoured brigade. The equilibrium was delicate. American CCKW engines could tolerate lower octane blends if necessary, but British Patton lorries preferred cleaner fuel to avoid pre-detonation under load. The result was that mixed Commonwealth formations occasionally reorganised their refuelling points, simply to match truck type with fuel grade. Every kilometre advanced was thus the product of hundreds of quiet calibrations. Human factors slipped into the equation too. Drivers who spent 12 hours steering steel-laden axles across rutted ground developed a tactile sensitivity that no manual could teach. They learned by feel when a wheel bearing was about to collapse, or when a gearbox needed nursing through a failing synchronizer. The war's greatest armies depended on these instincts far more than on any printed doctrine. The trucks may have carried the front line, but every so often the front line had to carry the trucks. As the conflict closed, the weight returned to silence. Convoys slowed, workshops dimmed, engines cooled for the first time in years. Yet the final consequence of this labour was not measured in tons hauled or miles covered. It appeared instead in the realisation that logistics had become the decisive instrument of modern warfare. The truck turned mobility from a luxury into a constant, and in doing so reshaped how armies viewed distance, supply, and time. The thought that lingers is factual and unembellished. The Allies won because they moved, and they moved because millions of wheels turned without ceremony across deserts, mountains, marshes, and ruined cities. No monument stands for that achievement. None is needed. The truck made victory possible by making movement inevitable.